Was there a duck you didn't like?
No, no, cock soup. Uh, I have this bunch of chooks out the back,
Oh yeah,
and they've
yeah,
sort of they've bred up naturally, bred up a little bit, and of course, 50% of the chickens are roosters, right?
yeah.
And it was getting a little bit out of hand. In the morning, it was like a fucking symphony orchestra. I mean, it was ridiculous, and the neighbours were starting to complain. So I went out, and one night I offed a dozen roosters from my backyard.
Well,
I, portioned out about half a dozen of them, and
yeah.
then this afternoon I put three of them in a big pot and filled it with water and put veggies in it and other flavourings and enhancements and made cock soup.
Oh, fair enough. They don't taste much different than other chooks.
No, they don't. Well, this lot's interesting because they were little, crossbred sort of roosters, crossbred with bantams and silkies, and two of them were quite funny when I plucked them. They had black leathery skin and black black flesh
Yeah.
too. Yeah, but they taste fine.
Um. So you pluck. So you did all the plucking yourself. Horrible job.
Yeah, absolutely. I grew up on a farm, so no problem there.
Yeah. I've only done it once. Um. It's definitely not a. I mean, I've eaten a few homebred chooks, but actually doing the plucking, I've only ever done that once. It's not a fun job. We didn't eat many of our chooks, I've got to admit. Um, Mostly just eggs. So go and have to get eggs. But occasionally, um, we do. But what is it? Rhode Island Red, I think we used to have. That sound familiar. Yeah, and the black ones. I'm trying to think what the black ones were. Can't think of it. Doesn't matter. But that was one of my jobs as a kid, going out and having to wander over the trick shed and get the collect the eggs. So
Yeah, we had to do that as kids too. We had about 200 chooks on our farm. We used to sell the eggs to the egg board.
oh
Every
right.
Easter, the Easter holidays, when the Easter holidays came around, we used to collect about, we go out one night and separate about 50 of them out, put them in like cages overnight. And then on Easter weekend, we'd knock about 50 chooks off and process them and put them in our freezer. And that was our sort of like supply of chooks for the year. So, yeah.
We never had that many. I think we only ever maybe about 20 or 30. We really only had a hobby farm. Um, well, I'd call it a hobby farm. It definitely wasn't commercial. It's like occasional stuff, but to nothing to as a living, because the main business was the uh, metal fabrication business. So building farm machinery, etc. So it was good though. I got to learn all the equipment and all the farm stuff, but we didn't actually make a living off the farm. What's that out there? We got Spooky. I got Larry already. I got a I see. I'm just gonna post this up here. What I might do is I'll share my screen. And that will save switching back and forth for a little bit. I just have to remember that I shared my screen and not to stick stuff up on there that we don't want to see. Screen, that one. Go live. So this is what I reckon that Blue's working on a video. So I don't know if you saw this post. Of Bev's over the bridge with his level that can't be level, because now that's got the camera on it, can't be surveyed.
Yeah, it's kind of like a bit too tempting for Blue, that one, isn't it?
Yeah. I thought I'd put a little one together with all the surveying references. You know, I've got that when he came and saw us at Christmas Eve, whatever it was. And he said, no, I've never worked a survey, never, blah, blah, blah. Went through, never done anything yet. Apparently he knows that you stick a camera on it, so magically it's no longer surveying.
Yeah, I know. You better throw out all your holiday snaps because you used a camera to take them, Timbo.
Yeah.
I mean, like, they're not actually representations of what you actually saw, you know, because you used a camera.
Yes, that's what I found really weird. Oops, sorry.
I know. It's just an excuse for Bev. It's a dismal excuse too.
Yeah. You could hear it that he knew that if he was going to set up a level, he had to have something out there because I don't know if he's smart enough to realise that it was always going to show this, that the level's well above too high, or whether he's just had to make sure that he didn't have another Blackpool Tower incident.
Well, it literally is another Blackpool Tower incident, isn't it?
Exactly. Yeah, well, that's right. So I want to see the rest of the stuff because supposedly there's all this other video. I don't know if you saw. Yeah, you probably didn't. It's a bit. I've got it listed on my running sheet here as drivel. I'll just put it up. Hanging off there. Where's drivel? Drivel. Pause that. Okay. Just got to set up so our friendly peanut gallery can see it. Wrong one. Where are you? Ah, there it is. There we go. This was popped up in the feed. You can see he's used the background from his what's he think?
And I already have the idea in my mind. Existence must be necessary to the idea.
And I'm not gonna leave the audio on because it's just too annoying. But he's obviously trying to make a new intro to his show, I'd say. And it's just this repeated rubbish through the whole lot of.
But the angles of a triangle do not add up to 180 degrees. Think about it. I have an idea in my mind that a triangle exists. But the angles of a triangle do not add up to 180 degrees.
Now, I have no idea who that guy is. Maybe, do you recognise him?
No, not just offhand.
No. And so I don't know what that's about. But anyway, yes, so Bev had posted that as obviously with that really annoying music that he does through the whole lot. Yes. I do have other stuff he's done, but yeah, he's obviously going to start using this stuff. He goes on about his in his channel. Let's put that up.
You have to imagine what you imagine and be able to vocalize it. Otherwise, I mean, what are you seeing in the picture? What is it? What do you imagine you're seeing?
Well, you don't have to imagine what you see.
Bridge 6 miles away. Some fantastic shots with the P1000. I mean, people were telling us they're really bad cameras, but look at that. Look at it. 6 miles away.
I still can't get over this. The talk as though they've magically discovered.
I know. Like, I don't think anyone says they're really bad cameras. I think they're just not the best sort of cameras, are they?
Well, they're not as magical as a lot of flat earthers make them out to be. They're somehow, they tell the truth and none of the other cameras tell the truth. That's the thing. It's just like, yes, they're...
I mean, after all, it actually has quite a small sensor on it.
Yeah. It's got a big lens, but a small sensor. So, it will zoom, but the quality's not 100%. I think...
Why? A bridge? See, but somebody stood on it.
It's like, yeah. What do you think bridges
You
are
watch
for?
cars go behind it. 6 miles away. It's a good advertisement for a P1000. And for us learning when's the best time of day to go and do it. Can't imagine what Rumpus would be doing. Even what his idea was. It's a shame he can't come and talk about it.
Yeah, well, I suspect that's more on your end than his end. I imagine Rumpus would just a little bit irritated by the whole process. I don't get it. Anyway. He wanders on with that stuff for a bit. I got a new panel. Might have to look at YouTube for this one. Here's it. Where'd it go? I made this new thing for before, just so that people watching it, the YouTube channel, get a bit of a warning. Bedford level ducks race. Yes. You should have done some more pictures of the ducks out there. There's a lot of nice ducks on the water.
People get bored of listening to people like Rumpus because he's all they've got. I have had a few things.
What do you mean all he got?
A few conversations. We're getting those things out.
So,
We're in the agents.
I got to put him on twice this. Even then, he dribbles on a bit too much.
This is FE Dogma. FE Dogma says, I say, horizontal is a straight line or plane with zero slope in any direction. And FE Dogma says, I thought you took a surveying class. Horizontal is perpendicular to the vertical at the position of the auto level, but yes. This line is a straight line that extends out from that position. Of course, a level line of equal elevation curves down from the horizontal, but over a short distance, this is quite difficult to measure. This is why your photos of Blackpool Tower are so nice, because over long distances, this drop is very easy to measure as shown in your photos. And I say,
with a ruler.
yeah, I say, you don't measure by putting rulers on a picture, do you? And he says, if the actual or angular size of objects in the photo are known, then yes, you can use the scale ruler to represent those sizes in the photo. So Ruhif has taught him well, the opposite side angle. The opposite side to the angle can have a ruler placed there in the picture.
Yeah, but what do you think a scale plane is? 3, 4, 5. What? Yeah. That's what he
What do you
calls
think
it.
the stadium marks in an auto level are? They are literally a ruler.
That's right. Anything you put any image, you can scale it if you know it's the word scale is
I
basically
mean, stadium marks are literally a ruler overlaid on the image, and you use those ruler marks to determine the distance.
using the angle.
Go figure it out, Bev.
That's just that's silly. How do you think the surveyors use it? You can't measure what you see. What's the point of doing it?
This is new scientific method.
It's the Blue Marble armchair surveyors, I'm calling it. They can find pictures on the internet and then put a ruler on them and do some sort of calculations and come up with his globe. I'm sure they can sort themselves out with one for Bedford. Hopefully, anyway. I'm hoping they can. We've got all of the material they could possibly need.
Yep.
Yeah, we want to calculate an elevation profile of Bedford. Should be quite easy.
You haven't done enough information to do an elevation profile, Biff. Don't know if you realise that. You don't do an elevation profile with 2 levels. It's just one setup. What are you doing, kid? Come on. Other way. Sit up there.
I've got some comment over there. Tartaria.
I spoke spoke's not the right word. Conversed with Alan briefly the other day. I saw him on Discord.
Yeah, how is Alan?
He's coughing up a fair bit. He's been a bit crook. Yeah, saying he's still coughing pretty badly, which is why he hasn't.
Oh, that's no good.
Why he wasn't coming on. I don't know whether that's still the same case today or not, but if he's usually pretty reliable, so if he's not here, then he can't be here. So, it's just basically the. He said he was coughing so hard that he actually pulled a muscle the other day, which is not great. But hopefully he's able to resolve that. Let's see. I'll link further along. So go back up here.
I haven't been to Bev's channel for ages. Have no idea what's going on there. And you know what? I feel great about it.
Yeah. Fair enough. I think it's all very much the same. It's like this. I think he'll drag these few images out for a while. Then I'll get a little bit more.
I mean,
his other
last
games.
few times I actually looked on his Discord channel, there was nothing but bot postings. That's all that I saw, pretty much. And bot postings and meme pictures. That's about it.
Yeah. Yeah. There's no sensible discussion. For a while, they used to have Darren. Like anytime they get someone there who's willing to do some discussion, they pretty much drive them away. So it's not as sensible as like a few other.
Yeah, because they're toxic. They're toxic, obnoxious pricks. That's why.
Yeah. This was more of the same.
That measurement is equal. It's the same measurement for use of making a mind map for us to go over with. So if that's your scenario from A to B, right now, this is an auto level, and the auto level at A is going to be established in a horizontal, and the auto level at B is also going to be established in a horizontal. That means at the point where A is, there is a perpendicular, vertical and horizontal, and where you've got B is, there's a... I suppose I could do that, couldn't we?
Because there's no way he's ever going to acknowledge that if the two horizontals don't line up with each other, that indicates that there's a difference.
Curve, yeah. This is why. This is literally why Bev won't do this test. He will not point to what are levels at each other. He just refuses to do it.
Yeah, which is why he tried to claim. And he said that supposedly they could only set up on one bridge and not with the auto level. But I couldn't see why they've only got one direction one way. Well, that's that I've seen so far.
Put a perpendicular at A. And that one there, perpendicular. Right, now. What are we doing with that? Where can we go mentally with this picture? Are you going to say, how do you imagine the perpendicular at A and the perpendicular at B in relation to each other? Well, let's say from A to B, there is a shortest line distance. Point A, point B, shortest distance from there to there. So that would have to be a straight line, the shortest distance.
Yeah. Doesn't have to be perpendicular though, too.
Right, then at that straight line would have perpendiculars being able to be placed.
No.
Now, would those perpendiculars coincide with the horizontal? Or would the line
No.
from A to B coincide with the horizontal established at A?
Well, you haven't even established that the perpendiculars are the straight line is perpendicular to your A and B, your plumb level at A and B. Yeah.
I mean, it's called taking reciprocal zenith angles, Bev.
Yeah.
That's what you're talking about. Why don't you just actually do it?
You were out there. You could have done it. Grab your auto level and shoot back the other way with someone standing on the staff on the other bridge. That would have been really good, but no.
And the horizontal established at B.
Yeah, it would be the same, for example, possibility. These auto levels are on the same elevation.
Equal the shortest distance from A to
Even that is wrong, because they haven't established that their sites are at the same elevation yet. All they've said is they've got an auto level at A, which goes to the water level, and an auto level at B, and then they're saying, equal elevation. Well, only if the level from the auto level to the water at both points is exactly
I think that's what they're trying to imply, that they're sort of assuming that they're actually set up at the same
But they haven't said that.
elevation. That's what the arrow down to the water level's trying to indicate, I think.
Yeah, but they haven't said that, though. And that's the thing.
I know.
You have to establish that. You have to prove that.
B would be the same straight line as you could establish a perpendicular at A and a perpendicular at B.
They may have said it earlier.
Because the shortest distance in reality
But
has to be a horizontal.
I thought I've picked this up just after you drew it, so...
Otherwise, you would be making a right angle triangle, right? You would be having the hypotenuse as the longer distance.
Isn't the hypotenuse always the longer distance? Isn't that the definition of it?
If it's not horizontal, right?
Yes. That would be not a long leg within a right angle triangle, but hypotenuse. So, or even not just side, because this would be not a right angle triangle.
G'day.
G'day, how you, mate?
Yeah, good.
It's good. How's
So,
things?
once again, I joined just when Bev's talking. Yeah, lovely, thank you.
Just happened to be put on. That was all. You started that.
Oh, is this the results of his?
Wait, so you missed my warning.
Okay, let me say his Bedford test.
It's just him. As we said, he's going to be dragging this out for
A long time. Yeah, of course he is. Making all kinds of excuses.
How many months, maybe years, do you think you'll get out of this? I don't know.
Oh, I would say at least a year, if not longer.
Because
You'll bring it up. I mean, this will go on every show probably for the next few months, and then after that, it'll dwindle out, but it'll still bring it up every now and again.
Because how long since they did the Blackpool, which was the last lot of images?
Oh, that was a couple of years ago, I think, wasn't it?
Yeah.
At least.
So you missed my warning panel. See that if you nick onto YouTube, you'll see I did warn you. So.
Never mind. Carry on. Carry on, Todd.
Right. Yeah, I just was gonna listen through his bit for a bit.
So, that would be isosceles triangle.
Well, we're not talking about actually looking through the auto level, because we're just hypothetically
Now, why would you do that?
imagining. I've got the question being, would the shortest distance between A and B be horizontal?
No,
Can anyone else think of a better question than that?
you'd have to prove it's horizontal. You can't stay.
Well, unless you dig through the earth, the shortest distance between A and B is going to be a curve, Bev.
Exactly. Shortest distance always, in this case, going to be a straight line. but you haven't established that that's
Well, it
straight
can be.
lines.
I suppose it can be a straight line if it's a short distance and you're at a reasonable elevation. You won't have to sight through the earth.
No, but he hasn't. His all he's established is that it's a line. He hasn't established it's horizontal. So for it to be horizontal, he'd have to prove that it's 90 degrees to the plumb at both A and both B.
No, I haven't put a distance on it because I'm not too sure. We keep doing that, Brad. Would the theodolite be? Would A? Would the theodolite be? Would the...
What's he looking at there? Whose is that? That's definitely not Bedford.
What's he talking about theodolites for? Bev's never used a theodolite. He wouldn't know how to operate one, I'm sure.
No, he'd probably set it at 90 degrees and that'd be it.
auto level? The crosshairs show the horizontal.
Well, don't forget he isn't a qualified, certified surveyor. Don't forget.
Yeah, he's the most qualified not surveyor that I know.
Yeah.
Yes.
A would be the theodolite, B would be the auto level. Crosshairs show the horizontal established at A. I don't know.
No, because you don't know.
What would
It's
you
a
call the
theodolite.
shortest distance between A and B then?
Straight line, but not. You haven't established it's horizontal yet, Bev. Even in this image you've got here, is established that there is a horizontal at A, and here horizontal at B. You still haven't established that they're both the same.
For me, it would be horizontal. Of this-
I've always said that all shortest distances measured are horizontal. That's why all...
What? What? That. I don't know if you realise how silly that statement is. So what's the shortest distance from the top of the water level to the base? Is that horizontal? Is the shortest distance from your nose to your toe? Is that always horizontal?
elevation profiles show horizontals as being parallel. You call it...
Sorry, what was that? That was a bit wrong.
What would you call the shortest distance between A and B then?
For me, it
If
would
they're
be
at the same elevation, then I'd call it
Right.
a chord.
It's a line. Yeah, a chord if you want. A line. That's all it is so far. It's a shot if you survey, you've looked at it. But yeah, you haven't established anything at the moment.
I've always said that all shortest distances measured are horizontal. That's why all elevation profiles show horizontals as being parallel.
No, it's not why. It's not why at all.
What is the shortest distance between the bottom and the top of a mountain a horizontal, Bev?
Yeah, that's what I said. It's a ridiculous statement.
You call
It
line
is.
of
It's
sight.
totally retarded.
But that's really interesting because I don't think that the line of sight is actually horizontal once you get over distance, I think.
The line of sight? No, of course not. Could be anything. I mean, through an order level, if the order level's set up and you're looking at the line, then you may have some statement, but you know, your line of sight is wherever you're looking. So you're looking to the top of a skyscraper from the bottom. It's not horizontal. Often mix up line of sight, and they always get it wrong.
Perspective error.
It may be horizontal, but it is not necessary because the line of sight is just the point where you are looking at. So
Yeah.
it can be anything.
I should have got that
only
right.
horizontal, any direction.
Yeah, but Brad's sort of looking at the optics through somebody else's auto level, and they've took a picture through the crosshairs, through the tool. If they've even said, you know, this isn't surveying, I think I'll go and have a look for that.
Well, it goes beyond that too, because Brad only has horizontal at point A or point B or point C. He doesn't have a horizontal between A and B or B and C or A and Z. So if he can't determine horizontal from point to point, then he can't determine a drop because he has no reference.
Is he Dan?
He has no reference to measure drop from.
Can you turn the video volume up a bit? It's pretty
Sure
low.
thing.
I'm struggling
Sorry.
to listen to it, Timbo.
Sorry, Matt. I'll put it up. I'll go back a little bit. Oops, not that much. There you go.
For me, it would be horizontal. Obviously.
I've always said that all shortest distances measured are horizontal. That's why all elevation profiles show horizontals as being parallel. You call it the line of sight. But that's really interesting because I don't think that the line of sight is actually horizontal once you get over distance. I think perspective error.
It may be horizontal, but it is not necessary because the line of sight is just the point where you are looking at. So it can be anything, not only horizontal, any direction.
Yeah, but Brad's sort of looking at the optics through somebody else's auto level, and they've took a picture through the crosshairs, through the tool. They've even said, this isn't surveying. I don't think I'll go and have a look for that.
Well, it goes beyond that too, because Brad only has horizontal at point A or point B or point C. He doesn't have a horizontal between A and B or B and C or A and C. So
I
he
don't know
can't.
who that is.
If he can't determine horizontal from point to point, then he can't determine a drop because he has no reference.
Do you know who was just talking? I don't recognise that voice.
No, no idea.
No, it's okay.
I don't remember his name. I did know his name. Irish, clearly.
Yeah, I know where
I can't, yeah, he does hang around on Discord from time to time, and he appears on some of his live streams, and I just can't remember his name.
So sorry, and obviously an OSC Larry, but I don't know who that one is. So
He has no reference to measure drop from.
I know Jesse Kozlowski isn't a real surveyor and all of that, but he is one of your gods.
that's really insulting.
No, Brad.
That's obnoxious, isn't it?
Yeah. Someone who's actually done it, as opposed to them who set up one auto level with one shot from one point to a bridge and then say, no, they're not a real surveyor.
Well, one of the shadow giants, at least. Maybe not one of the gods, it's a bit much. But they're in his own thing. He could just call himself a surveyor, so I suppose, as far as the internet's concerned, Jesse Kozlowski calls himself a surveyor. And he says, note, taking photographs
Yeah, it's because he is, yeah.
through surveying instrument telescopes is not standard surveying practice and is not to be confused with making surveying measurements using those instruments. These pictures were taken only to share the view as observed through the instrument telescope. Now, we've been saying the same thing.
I'm pretty sure that was in reference to very specific photos. Because you can do it as long as you make sure you haven't distorted the instrument. So if you set up your instrument level, then start attaching your camera, etc., then you may actually distort level. But if you attach your camera to the device and then make sure that everything's level, then what you're seeing should be correct.
And you have to make sure that the camera you attach makes an accurate representation of the image that you see with your eye.
Yeah, that's right. I think that's anything. And we're not talking about, measuring to millimeters here. that's the issue too. We're only looking at we're looking at gross distance errors of meters. So
I mean, putting a camera on the back doesn't change what the instrument actually sees.
No, that's right. As long as I said, as long as you've made sure that putting the camera on the back hasn't changed the level of the level, the auto level is still level, it's still setting itself up correctly, then that should be fine.
Well, on an auto level, that's not an issue because the compensation should ensure there's level, right?
In theory, you should be seeing the correct level, yes. As long as you haven't grossly misaligned the machine. Yes, you should be right.
Actually going to listen to it, right? But unfortunately, there's people like Brad out there that disregard this and think they can actually put a ruler on a picture. Jesse Kozlowski's taken. Or anybody else, right? Any picture that they've found on the internet. Jesse said that the water level drops. It's a measured drop. Measured drop, Blue. Jesse is not a surveyor. I'll get the clip for you, just in case.
What would you know, Bev? What a surveyor is or isn't?
Yeah,
he's not qualified to determine who is or is not a surveyor by any means.
No.
Jesse, what was it Jesse said? Oh yeah, it's measurable. Wait a minute, let me get it.
Sorry, VV.
In the live chat, 9 seconds.
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
There you go. So if anybody wants to know who started all of this, that's the guy, Jesse Kozlowski.
He started this. It was established long before Jesse existed.
get the, oh yeah, it's measurable as well. Do you want to hear that? Oh yeah, it's measurable. It's a pity nobody can. Calculatable. There we go. Oh yeah, it's measurable.
Oh, yeah, it's measurable.
Aye.
Yeah, I think he even asked me if I'd ever measured it.
It definitely is. I don't know. I don't even take much more, Bev. I do. There's something different. What else have I got? Oh, God. Oh, Matt's here. And Jackie. I know you were here earlier, Matt, but I found something. But I'll just see if I can find this guy. I thought you might like this. Have you seen this guy? He has some interesting shorts.
So I've previously covered that the Earth has a lot of space trash floating.
What's that, sorry?
Interstellar News, yeah, I'm not subscribed to him, but he keeps coming up on my recommended videos, especially the shorts.
Yeah, he's mostly shorts.
Yeah,
I'll just finish this one.
Astronomers may have discovered scientists. Astronomers may have discovered a baby planet forming around a star right before our very eyes. HD 169142 is a protoplanetary system located about 380 light years from Earth, and when stars are young, a collection of gas and rock orbits around them. Over millions of years, that dust and...
What's that, man? So it's a bit loud now.
380 light years, that's not far, really.
Yeah. I'll have to see if I can turn you down. Probably turn him down a little bit. I had it turned up for Bev.
material condenses together to form planetary bodies. It's a rare occurrence to actually be able to observe this process happening, and these photos show a baby planet carving out its place within a protoplanetary disk. This also happens with ringed planets we observe in the universe and right in our backyard with planets like Saturn with moons forming out of its rings materials. Astronomers believe that while this may be a baby planet in age, it is certainly not a baby planet in size. They believe that this is a gas planet and it is roughly the mass of Jupiter, and it's still in the process of forming. Through further observations and research of this developing planet, astronomers hope to learn more about how our own solar system and Earth itself came to be. Astronomers may have discovered...
I'll just see, go back. What dragged me to him? I'll just see if I can find the short. Not sure how old it was. I've got a link to it if I can't see it. Because he has lots and lots of shorts.
Yeah, he seems to be mostly shorts, wasn't it?
Yeah.
Yeah, how I keep seeing him. He keeps coming up and recommended, and it's always a short.
So I got this one. This is what.
On, of all days, NASA recently discovered an asteroid that may hit Earth on, of all days, Valentine's Day in 2046. It has been named 2023 DW, and even though it was just discovered a few weeks ago, it is at the top of the list of asteroids that poses the greatest threat to Earth. The asteroid is about 50 meters wide, and current estimates range that it has a 1 in 400 chance to a 1 in 607 chance of striking Earth. But you know, since us humans, we love to freak ourselves out, there was a chart that was made showing a line where the asteroid could potentially hit. And one of those spots is, of course, Los Angeles, which, you know, means that there will probably be a disaster movie made about this starring Dwayne Johnson. Now, if the asteroid were to hit, it wouldn't destroy the whole Earth or anything, but it would completely destroy the area or city that it does hit. Plus, with it being around 50 meters, there is a good
really
chance that
how
it breaks
dense
apart
it
and
is
explodes.
in the day, doesn't it?
Yeah, 50 meters.
If it's not, yeah, if it's one of those kind of loose rocky ones, then it'll probably break up pretty quickly in the atmosphere, I would suggest.
I think he suggests.
It depends. So.
I think he suggests that
in the atmosphere before it ever hits the ground. More calculations still need to be done to get a more accurate prediction on if it will or will not hit Earth, but the chances of that happening are still really low. NASA recently discovered it.
What was safe? It's
yeah,
like
everybody freaks out about it when they hear about these things, especially the conspiracy theorists. You know, they kind of like the doomsday thing and all the rest of it as well. You know, they freak out, but it's kind of like, well, hold on a minute. It's 50 meters. I mean, even if it was pretty solid, right? Okay, yeah, if it hits something, it could probably wipe out a town, maybe, possibly heavy damage a city. But I mean, you know, what are the chances considering what's the percentage of the globe covered in water surface?
Well, that's the plotted possible impact.
Yeah,
If so,
exactly. So
It's-
chances
there's-
are it's gonna the highest possibility is gonna land in an ocean somewhere, isn't it?
yeah,
You know,
yeah. And that,
even,
well, that,
even if it did make it through the atmosphere.
to 1 in 400, 1 in 600 is pretty low odds, although relatively high. But I mean, as he said, it could break up in the atmosphere, and also may not even come close. But
Yeah, most likely. But again, we don't, unless they know the composition of that asteroid, and, what the mass is and what the density is and all the rest of it. Then
But-
we do.
but it's
we don't
okay.
know yet.
You and I are safe. We're safe because it's not going to hit Australia.
Yeah,
and
we're okay. Yeah,
it's
not
not
everybody
gonna-
else. It gets closer to you than it does me.
Yeah, might hit a bit of Indonesia there and Malaysia, bottom of Malaysia. It's right across America, so that'd be good. Well, not so much good, but yes, I can see a movie be made about it because again, the path's right across the middle of America. There.
Yeah. Yeah.
I don't know.
I mean, we can sort of say all this. We can be sort of, it'll be all right. But I mean, one of these days, it could happen. It's going to happen at some point. It might not happen in our lifetimes or even our children's lifetimes. But one day, there is going to be an asteroid that's big enough that could do some serious damage to the planet.
Yeah, it's
Or at
always
least
possible.
make it uninhabitable for us, maybe.
It's always possible.
I think the Earth itself will survive, but we might not.
No, not all of us, maybe. Yes. So, I think we got more. So, hit. What was one? There's one he had a bit. Yeah, this one, I think.
Yep.
Did I turn that off? I did.
SpaceX has been developing the Starship for over a decade. Its goal has always
some
been to
news
play
about
an
that.
integral role in
Oh yeah.
Yeah, FAA have cleared Starship for launch, and they're targeting this Monday,
Okay.
0600 Eastern Time, which I don't know what that is for you.
No
that's,
idea.
That's about 12 midday currently for us with GMT plus 1.
0600
Around
Eastern
about
time.
12:15. Yeah, when the window opens at least anyway. Yeah, what is that? What time is that for you?
I just have to look at it. Let's have a look. Time. What was it? 0600?
0600 that's
Eastern.
Eastern.
Eastern. See if it comes up with a converter. 8 p.m.
8 p.m. for you. That's not bad.
It's okay.
Yeah, I think I'm gonna because it's 12 midday. I think I'm gonna live stream it. So
Okay.
being well.
That's right.
I mean,
So what-
I've cancelled my vMix subscription because I can't afford it at the moment. So I'll have to use OBS, and I just hope it works again because I haven't used OBS for a long time. So I just hope it works.
Just set it up beforehand. That's the thing. Yes, because you haven't used it for a while.
I'll probably do a test on Sunday, maybe Sunday night, see how it all goes.
I made the
As long
mistake
as they
once.
can actually hear the broadcast, and not if they can't hear me, that doesn't matter.
I made the mistake once of clicking on OBS and doing an update just before I was about to go out and stream.
Yeah, it's all changed now, isn't it? It looks a lot nicer, actually. It looks easier to use, actually. I've just been sort of fiddling around with it this morning, and yeah, it looks all right, actually.
Yeah, well, I've got mine set up really well. I can got enough scenes and stuff set up, and we can change the layout. Yeah, I don't mind it. It's good enough for what I'm using it for at the moment.
Yeah, so anyway, for this orbital test, neither the booster or the actual Starship orbital stages, they're not going to recover them. It's just going to crash. The booster's going to crash in the Atlantic somewhere.
Okay.
And then the Starship itself is still going to go through the process as if it's going to land, but it's just going to smack into the Pacific, I think, somewhere.
Okay. Fair enough.
Yeah, so they're not going to recover either ones. But then if that all goes well, then we're probably going to see the magic chopsticks, as they call it. You know, when it catches it on the launch pad.
That would be nice to see.
It all going well. Yeah.
Nice to see.
Yeah. Well, they're going to try at least anyway.
The logic behind it.
It could be interesting. I think there might be an explosion somehow, but who knows? Could be wrong. I hope I am.
I got some CC here. Hang on a sec. Or do we want to have some? Do you want to have some Lindsay, so you can go get a cup of tea?
I've already got one anyway, so I'm right. I literally just had one. So okay.
What are we gonna do? I clicked this one, so I've already clicked it. So I'll pause it for a sec.
All ready to go.
Yeah, let's do this.
Lindsay warning, everybody.
Lindsay warning, yeah. I got it.
Are we
What do you
going to do
reckon? Why not? I got it going. Not doing very well, actually.
Good.
Last few times we've done this, sorry, I just had a few in.
No, I haven't done well either. No.
Maybe I need to take some out. So black holes. Paul, I think thinks black hole's a good one.
Yeah, vortex is a good one.
It's not just black hole; it's black hole of creation.
That's right.
Well, the other one he's had in the Milky Way has come up a lot. Sorry, milk. Put a K in here.
I think equilibrium should come out because equilibrium's like you can use equilibrium in all kinds of different contexts, couldn't you?
Let's get rid of waters beneath because that's not very often. Beaufort Gaia, no, get rid of that. Pineal gland, get rid of that.
I think the rest of that is alright.
We might get rid of we'll reduce it down to the more ecliptic plane as it was pretty common. Cold fusion might get it.
Yeah, I think those ones you got left are pretty good.
Yeah, he hasn't mentioned them for a while. That'll do. Okay, let's see where we get. Oh, we do you first, Matt.
How many is that? 1, 2, 3, 4, 5, 6,
7.
7.
That's alright.
That's plenty, I think. Go on then. Spin me.
There you go. Tropical gap. That's not
tropical
bad.
gap. Oh, I like that one. I've had that one before. I've guessed that one and they got it.
Just making no. Okay. Let's see what Paul gets. We remove that one. Actually, I should probably go first. That gives been the host. That gives people a better chance. I'll go next. Ooh, Milky Way. Okay, remove that one. And Paul is going to have... vortex. And
Vortex.
Vortex.
So who got vortex?
Paul. Paul's got that. And we'll do
Right.
So you got vortex, Paul. We'll do the peanuts. Peanuts can get... Okay, peanuts. Taurus field. Or anything Taurus, anything related. You can have that one. Let's see where we're at.
What did you get, Timbo? I was talking to somebody else there. For a
What did I get? I didn't write it down. I don't know. I think... Milky Way.
Milky Way. Oh, that's that's a good one.
Yeah, that's what I got. I did write it down. I just off the screen. Okay. That's a pretty one. Ooh, the title. This is, I reckon we should do him for false advertising because he puts up the titles, right? This one's, and it's Jules' son. Almost always, it's never what he says in the title. Sometimes he's put off in it, last week. Last week was, he didn't even mention anything that he had in the title. So, I don't know. Maybe he doesn't even know what video he's putting up. Who knows? Okay.
So I've got tropical gap. Come on, Lindsay. Tropical gap. Give me tropical gap.
Okay, we put on Lindsay speed. Let's go.
Welcome everybody, welcome to another physics lesson concerning our flat earth realm we all exist in. Something that's not taught in schools. They don't want you to know the truth.
No.
My channel here is all about exposing the truth, exposing their lies and showing their downfall. Or
not much evidence of it.
Trying to
but anyway.
create their downfall and represent the truth.
Oh, he's got the tropics at the top left
everybody's
there.
been fooled.
Oh.
It could be
It's all
pretty
about
good
money and
possibility.
control.
You might be.
So this video is quite informative.
Yeah.
It's about the Sun dilemma, the dual system, the dual reality we all exist in, separated at birth in this physical world, come from a place of singularity, but separated, male from female are separated. So you have to bear in mind that we in the physical world are internally a singularity, a single system, but it's your duality is the spiritual, and this is what all religion's about, is connecting with the spiritual inner self, the unification, coming home, they say. Like in the Yellow Brick Road, she goes off searching, looking,
They say,
and
who's they?
very happy to come home again.
Who's they? I want to know who they.
I don't know who they is, and also he doesn't know his.
They is.
He doesn't know his Wizard of Oz because she doesn't follow the Yellow Brick Home to get the Yellow Brick Road to find home. She finds it to go find Oz. Just wandering off to find out about the world she's on.
Yeah.
So, anyway.
It's a spiritual story, but nobody sees that in that movie, obviously. But anyway, let me just get on into this video. So here we have the globe model, the globe nonsense. Now, in the globe model, someone's just recently pointed out, which makes total sense with all my videos, because everything is a dual and a mirrored image. I've never stopped and thought about that. Pointed out the fact, and it's written, it's in science. I've got it go on site, you'll find it on the internet. That there's two
Turn them
sun
up a
and
little
11.
bit, Timbo. Maybe.
Turn him up.
Yeah, turn them up just a little bit, not too much.
Oh, I must have this turned down a bit. Hang on a sec. Because it's really blasting in my ears. So.
Oh, is it?
do this.
Yeah, on
Yeah,
here it's
so-
a bit low. Not
One
terribly
each
slow,
hemisphere.
just a touch.
And this is how they're positioned.
Is that better?
There you go.
So
probably.
one could
yeah.
argue that would make sense because you've got the bigger part with the wider bulge of their ball, and there's the wider part of their bulge of the ball. But how can this be if there's only one sun?
There's no way he'd work it out, would he? That why it's different from southern hemisphere. That's the way it should be if there's only one sun. And it's not to do with it's to do with where the orientation of the viewer is. The question would be, what happens at the equator?
Well, in reality, there's not just one sun. That's mirrored as well. There's also a sun down here. There's a sun in the north, sun in the south. Two Milky Ways. We can see them. You can video them.
Really?
Really? So you just have this. Okay, somehow you cross the equator, and then
So
if you're standing on the equator, you should be able to see both.
So in the southern, what you're saying is that right, yeah, you should. I mean, whether you're at the equator or whether you're in the northern or southern hemisphere, you should be able to see at least two suns, right?
Yeah,
but we don't. Why don't we?
Somehow miraculously, you could flick jump from one side to the equator to the other, and have the sun appear to the south of you, and then appear to the north of you, and then back to the south of you.
I'm sure at certain times as well, if you're living on the equator as well, you probably should be able to see three suns at different times of the year, maybe as well. But
yeah. This is the thing. There's no proof for any of this. Time
lapse, whatever. We all see the Milky Way move across us. We don't live in it. If we can see it moving across us, and the sun is in the Milky Way, so we don't see the Milky Way during the day, obviously, only at night. So if it's tucked in like a, into a, imagine the sun being tucked into a pipe or a straw, like an eye set into its socket or the egg set into a nest. There's only going to be one side reflecting out, just like our eyeballs. It's part of nature, isn't it? So, and as the Milky Way turns, it's going to turn away from you. And so it's in there. There's daylight.
Did anybody have Milky Way?
We used to have Milky Way. We haven't had one for a long time.
No, did anybody draw Milky Way in the spin?
Oh, right. Don't know. Yeah,
I think we did.
I did.
Oh, you did? Oh,
Yeah.
nice. There you go. 1-0.
Sorry. I think I was up about 3. But anyway, okay.
Oh, was he? Okay, fair enough.
He mentioned it a few times already.
Oh.
Well, it's turned. Now it's night time. That's the back of the sun on the Milky Way.
Oh, that's the black hole on the back of the sun. Got to remember that.
Sagittarius A, they like to call it. How many people have been fooled into believing that? So understand the dual system. It's not a ball. It cannot happen like this.
But it does happen. That's the funny thing.
So what? So he's got the Earth tilted there, but why has he got the sun rays at an angle, pointing directly at the equator? What? Why?
It's very, he doesn't quite comprehend the tilt, does he? Anyway.
Look, sun rays. Sun rays would have to be direct towards the tropics or equator to have a constant equal mirrored image.
No. It
No.
wouldn't. That's the thing. That's where you don't understand what you're looking at.
North to south. For that to be mirrored at all times, any time of the year, even though it does vary, but it will always be mirrored every day, the sun would have to be dead centre, wouldn't it? Yes, but it's not. The sun moves. Now, if you go with their theory and have the sun coming in this direction because it's the southern summer, how would if you've got one sun down here shining this way, well, what creates this? It cannot work.
Because we don't have a sun down there shining that way. That's why.
No, no, we don't. What?
That's why it doesn't work, because it doesn't happen that way.
Because
the sun is basically, if you're looking at the Earth that way, I suppose the sun's going to be over on the right-hand side of the board, over that way.
Yeah, so that
It doesn't. No.
if his image is close to being correct, the sun should be parallel to his board. You know.
Yeah. Yeah.
theory is that Earth's tilt is what creates the discrepancy of the two loops, between the two loops. So they have one up here.
What? No, it's not. That's not right, is it? Is that
What are these two loops then? Is he?
No,
Are those two loops supposed to be? Go on.
The Alama. What do you call it? I've got the word, not Alamea. What do you call it? The figure eight.
Analemma.
That's-
Analemma.
Analemma. Yeah.
An element, yeah.
Yeah, so that's what it's referring
Oh,
to.
an element
right?
of the sun. Right. Yeah, good.
Yeah,
Yeah, but that's
so-
throughout the year. So
Yeah, it doesn't appear one day, and then you've got to take. You got to take
it
the
doesn't
same.
doesn't go in that. It doesn't go like that during the course of a day. You know, that's
Yeah.
what he's almost like he's insinuating.
Yeah, and that's what he's got it wrong. But that's what he said before was wrong. You know, that it's not it's not the tilt that causes the problem.
And if the sun's this way, you know,
The sun's not that way.
that's diminished
No.
because of the light of the sun. If the sun went right up here, they would say, oh, you'd have the bigger loop here. Well, the sun coming this way, you'd have this bigger loop here, yes. But we've got two here. You can't explain that.
Yeah, we
That
can.
might be plausible if there was only one image. LOL. You can't have this. What?
But there is only one image, and first of all, he's not right. But he's got this idea that he just can't visualize the 3D that somebody's standing on the Earth here, and then he's going to see this, and somebody standing down here, and it's going to look up relatively. It's going to be the opposite direction. It's the same with the moon, you know. Anyway,
He can't even get his own. You can't even get his own model right. Like, let alone the real model.
you can't get what is claimed, right? Let alone,
No, exactly. Yeah,
So-
that's what I mean. Yeah. So he's getting his wrong.
Well, because he's making claims that don't happen. He's saying that it's wrong because you can't have two images. And we're saying, but that's because there is no two images.
But then but then he explains it and it's wrong.
yeah,
What?
his premise is wrong in the first place. Yeah.
What they tell you with the two images.
It's
They
wrong.
don't teach you that at
isn't it? All
school.
of it. It's wrong.
No, but I asked that question and they have to admit it online. The truth's there if you ask the questions. Any astrophotographer should know that nothing crosses the tropics, but they do not. Because they know nothing about reality. Only what they have been told, taught, and indoctrinated into believing.
No, it's the astrophotographers take the image at the. So, my understanding is, if you take the image from the equator, it's still going to be a little bit halfway between the two, I think, isn't it? Roughly.
I suppose. Yeah. Uh-huh.
Yeah, I'd have to go get what one, because they're going to look slightly different depending on whether you're taking it from the top or the bottom. Or is it the... I'm just trying to visualise here. So the shape is mostly because of the way we travel around the sun, and then the angle that we are at that point as you go around. Yeah,
And the tilt.
the tilt. I'll have to look into that to see. if I can find an image. I won't do it now, but find an image from Northern Hemisphere equator and Southern Hemisphere. But anyway.
There's two rotations. Two separate star rotations with a gap. They do not merge. They do not merge. The night sky does not merge. There's Orion's belt passes through here. The tides down on Earth, the currents don't merge. The water's obviously merging, but the currents don't. It's the divergence in this tropical region, this gap. It's the dielectric. Everything gets diverted away. The winds do not cross. They get diverted back this way. And the magnetic field is in the wind. So why would they think the magnetic field would cross if nothing else crosses? 100% proof you do not live on a globe is right there. I'm the only one who's proven that, can prove this and has declared this. Science knows the magnetic field is...
You haven't proved anything, you've just declared it. Yeah. You have to prove it, you actually have to see it. Yeah, this is what we want. I'm just trying to find an image. Sorry, I'll play this.
The weakest point here, and because it's weak, they failed to detect the fact it does not cross and it drops straight back down to Earth. Goes through the Earth and back up at the poles, crossing over. Science wants their cake and to eat it also. They can say the larger loop is due to the central position of the ball, this wider bulge.
What?
Position of the ball Earth, and by means of the curving ball. But they have to admit there are two images mirrored.
What? Where does he get the idea that it's because of the curve of the ball? I suppose where does he get any idea?
Sorry, I
Two
missed what you
separate
said
images.
then. Sorry, I was told.
I just say where does he get the idea that's the curve of the ball? That was his statement. I'm just trying to find out. Is it two images? I'm just looking through on the...
I wouldn't try and make sense of this, Timbo. I really
Nah,
wouldn't.
probably
You're just not. I wouldn't bother.
Images of the sun's inner limb is 100% proof that the southern hemisphere has a mirrored image, reflection of all the northern celestial bodies, e.g.
Wow.
two Milky Ways, etc.
Well, that's not true, but anyway.
Way
But-
again.
Because people don't understand the
Yeah.
model,
I think
they get out there and start looking, well, they don't see any alignment.
I'm about
No, if you understand that model properly, you have to
Oh,
imagine
really?
you've got the
Okay.
small centre northern hemisphere with this big, wider, dispersed southern hemisphere. So this one image is now spread out all around the southern hemisphere. It's all spread out. It's all expanded out. So you have to know what you're looking for to get a direct alignment for the mirrored image. And because on top of that we have the curving magnetic field lines that all these follow. I mean, this is the northern hemisphere, just one. The curving field that everything travels in. It's all spiraled up from the centre. This is called in celestial navigation. Go check out what is the spider web. If they know if you travel across the earth using a compass, you're moving in this curved path. But now we have the laser gyros. Everything's starting to change. So we can just go direct, avoid all this curving. This is why we have the...
Ooh, we can go straight lines now. We don't have to follow the Earth. We can go...
Yeah. It was like you mentioned about the ring laser gyros, and apparently everything's beginning to change. Is it?
Yeah.
What's changing?
So we don't have to do this curving thing now. We can just go straight, he says.
Yeah, that's right. You don't have to do the curving thing.
The nautical mile, which is not on the top of my mind at the moment. No, let's not go there.
No, because it...
In minutes, not minutes. Let's not go there. So, the flat Earth model shows us the sun comes out of the Arctic and one comes out of the Antarctic in a mirrored effect. I've shown this in earlier...
But it doesn't come out. We never see it south of us. That's not that
Yeah,
far
nothing
south.
comes. No, definitely not.
Why does he say hemisphere? Yes, Judy. He has mentioned before the hemisphere is the wrong term, but that's what he says. He has to use that so people know what he's talking about.
videos. It's more obvious at each solstice because we see the sun in the south there come more southeast, in the morning and disappear more southwest. It's just proof that it's coming from that southern direction. In the northern hemisphere, their solstice comes more northeast, travels across the arc of horizon, and goes around the back of them northwest. NASA and their paid puppets in the science world only mention the southern diminishing arcs of longitude with their ball model. This is their only sucky thumb blanket they can hold on to.
He didn't explain why that's a problem.
They certainly don't tell you that time travel between arcs of longitude are all the same, especially if you are using laser gyros, not compass bearings.
It's a funny thing I get is that
Time travel.
yeah, well, he's been saying for a while. I don't know if you noticed that because he believes that obviously everything's spidering out from the North Pole, right? That the explanation for why when you're in the southern hemisphere that the distances don't work up is because of this time travel. Is that it's gets distorted when it gets past the equator, and
All right.
so the time is different. So you're travelling this distance, but you're not. You're travelling faster than you think you are. Well, basically, along, as much sense as you can make about what he says.
Yeah.
So that's why the distances aren't correct, because he says they're all the same. And he actually said in one of his other videos that the distances between the lines of longitude, between two lines of longitude, are the same from the North Pole all the way through. It just gets distorted through this time dilation or whatever word he wants to use for it.
Yeah.
So as we go out from the centre of the Earth, like this is the northern hemisphere, you've got the tropical gap, then you've got the big southern field.
Tropical gap, you get one peanuts. Oh no, you had Taurus.
Yay.
You had,
No, that was me.
Matt had tropical gap. There you go.
I got one.
Got one.
About time.
Around here, you've got the curving field. It curves more towards the Tropic of Cancer here. And it curves this way too, more at the Tropic of Capricorn. Because you're getting this more curving, you're travelling further in the wrong direction. So because you're doing this extra travelling, this is why they come up with the ball idea, thinking you're coming out further on their ball. You get it? No, you're not. With a light laser gyro, you'd soon prove that you don't live on a globe, but they don't tell you that because they control the whole navigational system, don't they?
They don't control the whole navigation system. People can do it. They want to do it themselves.
They control it. Controlling where
GPS,
everybody navigates to now.
Yeah. Well, no, controlling all the information. So yes.
Yeah.
I think
Well, that's the same thing.
if the world was controlled by them, you think they'd be doing a better job.
Them and they.
Yeah. It's a bit disjointed for them who control everything. They're a bit not doing a very good job. Anyway.
Everything. You just travel straight. Bearing in mind you have to avoid all the land masses, so you're going to be going all over the place anyway. So that's it, guys. It's all about the mirrored effect, the dual system. Our whole realm is a dual system. Get that in your head. There's some guy on YouTube, there's a big following, keeps telling you it's not a dual system. He's a liar. He's trying to divert you from reality. We come from a place of singularity. He might be talking about the place we've come from, but we exist in this earthly realm as a dual system. Everything's a dual system. There's always a counter forces. You've got some counter forces going on with male and female in our relationships, haven't we? Yeah. Well, you've got up and down, in and out, positive, negative, black, white. So we have a northern hemisphere and a southern hemisphere. You spin this around, the two hemispheres of the human brain with a gap.
I still always get this thing that somehow this magical thing happens at the equator, but anyway.
Same thing, we're all related. We are of the earth, we are one with the earth. So we are separated at birth, so we go out looking for our other partner, our match, to find the love. Love is Lord, and good is God. So good and love is within you. You are your own God. You get that balance right, love and good and an open mind, this is when you raise your cross in the religious story. But that'll be my next video, so check that one out. I'm going to explain everything.
Yeah, that worries me a bit. You start saying that you're your own God. basically saying
He always
you know,
promises he's going to explain everything, but he never does.
he never does. It's never in the next video, is it? Next video is about something completely different. You always feel like you're missing something. You know, he films in between and doesn't put it up. But yeah.
No, it just doesn't.
Your theologians, the Jews, they don't know the whole story. I'm going to explain it all. You can believe me or not. It's up to you. But as the story goes,
I'll choose to not.
Yeah.
I'm a bit that way too.
A lot easier that way. Yeah.
Through me. What did I just do then? No. Me. As in you. But I am the one. You can pay me. Don't pay your churches. Pay me. I'll give you the truth. I'll answer all your questions. But
Give me money.
What happened to that thing? Wasn't he wanted $500 or something or other, and he'd tell you the truth? Wasn't that a while back? Was that him?
Something like that. Yeah.
he was going to set up this, you know, pay him and he'll tell you the truth.
No, me is actually you. Within me. Within you. But I'll tell you more than any of your churches have ever told you. So bear that in mind. Check out the next video.
Yeah.
Thanks, guys.
Yeah,
Thanks for
tell me
watching.
more. Just
Any
more
questions, just
bullshit,
ask.
basically.
Yeah, more rubbish.
Pretty straightforward. Once you know what that is. Cheers.
Cheers. Bye. Yes. That is pretty typical. I'm afraid I won that one. I'm a lot sorry. Lots of Milky Ways in there.
I think you did, yeah.
Yeah.
By a long way. How many times missed up? About 9-10 times?
Yeah, I've got in here, I've got 9 times I counted.
Yeah.
Only one tropical gap and didn't get any others. No vortexes, that was a surprise. You get one of those. But looking at the height of the doorknob.
So bear that in mind. Check out the next video.
Okay. If that... It is high. Yeah. Yes, Joe, that's correct. There are 2 knobs in that image.
Yeah. One big one and one on the door.
Yes, I do understand, Judy, because if you look at the hinges, you'd expect the doorknob to be down about the height of that second hinge, the lower one. Yeah,
it's a bit high, isn't it? Yeah.
Not that that's a problem, it's just a bit weird.
It's a bit weird.
Maybe it's a cupboard. Might not be. It could be a cupboard door. And maybe that's just where it is. I know he films these when his missus goes.
But even then, even if it was a cupboard, I wouldn't put the doorknob that high up.
Yeah. I got another video of someone who films when his missus isn't around.
CC.
Hey, so this is what you get when you're chemtrailed all day long. All day. You get a nice milky sky. So if I was to try to even look for the sun as it goes away right now and try to capture it, there's not a chance because it's in the backdrop of a nice chemtrail day. It's nice, isn't it? Yeah.
So clouds didn't exist before airplanes? just saying.
It's great. Yeah, but you don't see it. They're those are just lines in the sky. They're there to protect you, shall we say?
No, they're not.
Sure.
Never said that.
It's a Friday, and I like to give you a think about it Friday, just in case if I'm unable to put a video out. Look at this guy. This guy's going fucking 100 miles per hour. Unable to put a video out.
What's that outburst about?
A bit of road rage there.
Yeah.
There's a little bit of road rage. He has rage generally, so you got a little bit of road rage.
Sunday. When you purchase a car, a vehicle, okay, look at a magazine and buy it, right? You need to see it. You want to see that paint job on the car, that perfect finishing on there. You want to see the interior of the car. You want to see how much room you have inside of that car. A car purchase is the second most expensive purchase you're going to do as a household. So you really have to investigate this. You've got to find out what kind of car you want and all the features that are on this car, right? You need to find all of this out.
Okay, I'll just pause it there. Got any bets where he's heading with this?
You got to find out whether your car looks good on a YouTube video.
Probably. Particularly he puts the camera down to make sure he can see back up in here, because he's not allowed to film inside the house anymore.
And when you see the picture of it, that's not good enough for you. You actually physically have to go down there. You've got to touch it. You've got to drive it. Okay? You got to get the feel of that steering wheel. You got to get the feel of how much size you have in the trunk. You got to look at the size and the leg room. You've got to see everything before you purchase that vehicle. But it all began with a picture of that vehicle that you probably either saw on your phone or in a magazine. So you went to investigate that vehicle because you liked it. You see, now the problem is nobody is investigating the pictures that they're seeing of this supposed spinning wet ball.
There was all that to get to there. Yes, they are.
What if Fleur keeps saying spinning wet ball?
Yeah, I don't know.
What do you mean wet? I mean, what? Don't never get that.
They'll never get it. They have trouble with the idea it's a ball, so, whatever.
Nobody. They never have. They just saw a picture that's been stitched together.
No, wrong.
Wrong. The first pictures weren't stitched together. The very first one wasn't stitched together at all. 1945. Yeah, that one.
Yeah, it was a tiny bit of the globe.
Yeah, that's probably the first image. That wasn't stitched together, and then Blue Marble 1 isn't stitched together, and the other images. So, long time before the.
And all the rest of the ones from Earth. Okay, they're maybe not be full disc, but all the rest was from the moon.
So it's a long time.
None of them are stitched together.
A long time before you got a stitched together image.
That's been total bullshit, and they bought it. That's right, you bought it. You're paying $8 a day to NASA.
Personally,
$8. No, you're not. No, you're not
your
paying
hard-earned
$8
money,
a day
maybe
to
more.
NASA Americans. You're not. You're just not.
So what's it? Yeah,
he's taking that figure out of his arse. It's not even 1% of the total federal budget. So how the hell are you paying $8 a day? Don't be stupid, Chris.
Yeah.
Pull that figure right out of his back end.
I'm sure somebody's pulled it up, but it's obviously wrong. Like a whole lot of figures that come out.
Figure out what the computations are to that. Whatever it is, it's 52 or 57 million. It's probably up now with inflation. $60 million now a day. Who the fuck knows? They're just numbers. They're taxpayers.
60 million. Yeah, why not actually tell the truth?
Yes, he's just a bit. He just said who knows. He just, like you say, just pulled that figure out of his arse. He has no idea. He's no clue. He hasn't got a clue what the budget is.
So that's 0.02. Yeah, no, it doesn't work anything close to that. Yeah. Anyway.
Well, there are. It's our money. But you bought it, and you're paying for it, and you've never seen it. This is something to think about, isn't it? I'm a small channel with balls. You know what a ball is, right? Yeah, I used to think I lived on one. A spinning wet ball in space. I thank you for subbing. I thank you for viewing my videos. Let me be a part of your life.
Well, yeah.
So here's the thing. I was just doing a quick bit of research. So the fiscal year for NASA budget for 2022 it was 24 billion, right?
Yeah.
The last census they had in the United States, roughly 258 million were adults. So do the math. Hold on. So that adults would be the most taxpayers. I mean, not all of them would be taxpayers either.
No.
Well, I suppose one form or another. Maybe not income tax. Maybe I don't know.
Well, let's say they're not paying tax.
Work out to be.
Work out how much that per American would have per American. But I was
exactly.
If you did that for the military budget, why aren't you complaining about that? Dwarfs the.
Yeah, exactly. Dwarfs it completely.
Yeah.
Not even close. They actually spent more on the development of the F-35 aircraft, 7 times more than the NASA budget on one aircraft.
Yeah.
So you can imagine what the total federal budget for defence is in the United States. It's more than all the European countries combined.
I think
more than
once, and I'd have to check whether this is still the case. 200 times more than the rest of the world combined they spend on the military. But
oh, really?
I don't know if that's quite, but something like that. Yeah. So the next one is China, is below it, and it's a fraction of what the US spend. So I think the US could halve their budget, and they'd still be twice or 3 times as much as the Chinese spend, or something like that. So, yeah, I mean, their argument is that they have to spend that much money so that no one would dare attack them. But there's politically that doesn't make any difference. The amount of money you spend on a battle, well, you can see from the battles they've had in Afghanistan and a few other ones, the amount of money you put in there doesn't guarantee you a win on anything.
Right, it works out to be $93 per year per person. Right, so 93 divided by 365.
Yeah.
That works at 25 cents a day. A little bit different to $8 a day, Chris.
A little bit.
25 cents per day.
25 cents.
Or 25.4 cents, if you like.
I've got some more.
Yeah, 25 cents per adult per day. That's according to the last census, which was, fair enough, was in 2020, which is going to be a bit more than that, but it's not going to make that much more difference. So let's even say, for argument's sake, it's going to be 30 cents. It's still not $8.
No.
So where the heck you got $8 a day from? I have no freaking clue.
Shame Blue's not here. I had something for him. I got How to Fly. Do we know How to Fly? This was something in between. Hang on a sec. You should be able to see that, but our friends out there can't see that. Let's do that. There you go. Here you go. This is your. I figured every week, every show, I might try and find something so we can have a lesson on how to do stuff. So now you can
Like to Fly. Oh, we go. There's an old one. Have a lesson. Watch a YouTube video on how to fly and then fly.
They may be experts, you see.
This
So.
is the general layout of its
Isn't that how it works?
On the instrument board, we have the engine revolution counter, the airspeed indicator, which shows the speed at which the machine is traveling through the air.
Airspeed indicator. No.
Cross level, which helps you to keep on an even keel.
Moth, major moth. This is a
This
tiger
is
moth.
the altimeter, recording the height of the machine, and the oil pressure gauge, which has the same function as on a car. Here's the joystick, more correctly termed the control column, which can be moved in any direction. A sideways movement operates the ailerons, controlling the angle of bank in a turn. There are the ailerons moving. The fore and aft movement moves the elevators, which makes the nose of the machine go up or down. The The rudder is operated by the feet. All these three controls are used at the same time during flight. Engine speed is controlled by the throttle. Open, shut.
Magically.
Open, shut. And this is the ignition switch. Up for on and down for off.
That's it.
Petrol is carried here in this tank. When the tap is turned on, the petrol flows through this pipeline to the filter. Just a minute, and I'll show you.
I'll show you. The London Aeroplane Club.
Very old
There it is,
English accent.
and so to the carburetor.
Yeah.
Yeah, face of. There you go. See, you now know how to. How
Shocks in front of the wheels prevent the machine moving forward when the engine starts. Switch on. Oh, here we go.
Oh, that's a dangerous thing.
Yeah, it is, isn't it? Yeah.
Shocks are taken away,
Like
and
to
we
do that
taxi into
personally.
position to take off. The takeoff is always made into wind. And this type of aeroplane leaves the ground at approximately 40 miles an hour. There is a left-hand turn, left bank and left rudder. A right-hand turn, right bank and right rudder. Now you are in the air too. The controls are so sensitive and move so slightly that it is quite impossible to see their movements. As in taking off, we always land into wind. With the engine throttled back, we glide gently towards the ground, and again, at about 40 miles an hour, the machine drops lightly onto the aerodrome.
There you go. So you can now get your certification for being a pilot. Cause
Yeah, I'm ready to fly. Are you?
You've watched a YouTube video. So
Where's Blue? I need to tell Blue that I'm ready to fly. I've had my lesson.
Let me tell him next time we see him. We now know how to fly.
Yeah, just tell him. It's all right, it's fine. I know how to fly. I watched the YouTube video for 3 minutes. I'm ready to go. I'm qualified in a Tiger Moth. It's okay, it's all good.
Yeah, that's right.
I know you just love that accent. It's, it's a bit like the British public information films as well. It's kind of like that British accent. Love it.
Yes, I'm not sure when that was made. I figure it's probably about late 50s-ish. But yeah.
Yeah. Oh, yeah. No, probably late 40s even. Yeah. Get us through the filter here. Tally how. Oh.
Paul, do you have a hard quiz tonight?
I do, if you want to do one, yeah.
Yeah.
Might as well.
How about I'll put on some Everett and I'll set up a Zoom call while it's on.
Righto.
Yeah, hang on. I'll get the Everett going first. Position it there. Whoops. Hang on a sec. Make it bigger.
It's so fucking easy that a fucking 5-year-old could figure out that the Earth is fucking flat.
Who the fuck is this asshole? Please refrain from using any further obscenities in the presence of these people. What?
You think you're fucking spinning 1,000 miles an hour, but oh, you can't feel nothing. Yep. Oh, everything's fucking spinning, so nothing's spinning. Yeah, that makes a lot of sense.
Mr. Dumbass, I can bring a lot to Dumbass and Dumbass. I'm a go-getter. Dumbass material all the way.
Yeah, fucking gravity. Good one.
Gravity.
Magically holds
Look,
fucking trillions and trillions of gallons of water to a spinning fucking ball. Yeah, good one.
I've come back from the future to tell you something really important. What is it? You're an idiot.
Like I said, I used to be a globetard. I used to believe this fucking horse shit too until I actually fucking thought of it.
You got a lot of problems, don't you?
Jesus Christ. You fucking globetards are so programmed. I mean, it's just ridiculous.
So what can I do for you, Peter?
Well, Joe, I need to talk to you about something kind of personal.
Shoot.
Well, I took this test, and it sort of turns out that I'm technically mentally retarded.
You think you're living, clinging to the side of a fucking ball? I mean, who's the crazy one?
That's definitely you.
Do you fucking actually think the sun is 93 million fucking miles away? Are you that goddamn dumb?
I'm obnoxious
Yes, we
and
can, because you can
disliked,
prove
you know
it.
that, sir?
Yes, I know.
I'm obnoxious and disliked, you know that, sir?
Yes, I do.
He's obnoxious and disliked, and you know that.
So how could the sun or the moon go inside the fucking clouds? How could the sun go inside the clouds if it's 93 million miles away? If the sun was actually 93 million miles away, it would be a fucking beam of light, just like a spotlight or a laser beam or whatever, and it would be 93 million fucking miles long.
I don't care what every single person on Earth says. You're hilarious.
If you actually could think with your fucking own brain, like I said, you could easily figure this shit out, right? It's real fucking simple, right? Airplanes prove the fucking Earth is flat. Yep, that's right. I just fucking said it.
Soon we'll be able to look back on this and laugh.
Because if you actually lived on a fucking ball, a fucking spinning globe-tard ball,
You are ugly when you're angry.
you would actually have to literally look down, out the window and down to see the fucking horizon. But you don't. You look out and it's eye level right outside the airplane.
Hi, Cleveland.
Hi, Joseph. What's the story? Morning glory. What's the word? Hummingbird.
Have you heard Peter Griffin is slow?
Not one fucking shred of evidence. None. None. That prove you fucking on a spinning goddamn ball.
Still drive a car? Can he drink at a bar? Will they let him have kids? Is his life on the scale?
Hello, Mrs. Griffin. It's your neighbor Quagmire. Now that Peter's mental, you probably have some needs.
Words have fucking meaning, right? It's called sea level, not fucking sea curve.
Sea level.
It's called an atmosphere, not an atmostome.
That's right. Well, yes, it's C as in SEA, not SEE. Anyway.
Yeah.
For a start. And it's like, how big does he think the Earth is that when you get up in a plane, you look down, you'd have to look. His Earth
I
is
can guarantee he's one of these flat earthers that started out on Facebook because, yeah.
Yes.
Flat earthers on Facebook are on a different level of dumb. They really are. Seriously, they're really bad. Really bad.
Hey, Blue, welcome to the show. Did you see that we now are pilots? I don't know if you came in.
Yeah.
No, I didn't know that.
We're qualified in how to fly a tiger moth now, so we're qualified.
Yeah, we
Really?
just watched
We watched the YouTube video.
Yeah.
Well, way to go, fellas.
It was a 3-minute YouTube video. We know how to start the engine.
Plenty
we know
of
how to
time.
use the
Plenty
we
of
know how
time.
to use the yoke, the control thing, and that's all we need. That's it. We're ready to go.
Hey, it's easy, man. Nothing to it. Pull back, the houses get smaller. Push forward, the houses get bigger.
Bigger.
Pull back a lot, the houses get really big. In a hurry.
and they showed us a picture inside the engine, so we're now mechanics as well, aeronautical mechanics.
Yeah. It was a bit blue. It was a bit like one of those British public information films. It was that kind of accent, you know. Here's the filter. Yeah.
Yeah.
It's great.
Paul. Yes, we got to do it.
I'm ready to go.
Oh shit! Jesus is back. 50 ways to eat. Yeah. How to raise your children by eating gift. So, Paul, is that how where you got your IQ from? You've been eating gift to children.
Paul pulled that one out today, didn't you, Paul? That second book there.
Oh yeah, I did. Yeah, I made cock soup tonight.
I'm sure
the neighbours
you
were
did.
complaining about my roosters crowing in the backyard, so I knocked 12 of them off in the last couple of days. Yeah.
Right.
It's much quieter now in the mornings. It's great. So I put 3 in a pot tonight and boiled them up and made soup out of them, and it's actually delicious. Nice.
Yeah.
Cock soup.
Remind me if I ever visit Paul not to shout at his backyard because
It's full of cocks. My backyard's full of cocks.
Yeah. Everyone, Paul's eating cock.
Oh dear.
Right.
Okay.
What's the
Are you
eating
ready
gift
to
of
go?
jewelry?
We better go.
We better go. We
Yeah.
better go.
Otherwise
Only
we'll
got
run out
40
of time.
minutes.
Right?
Yeah.
Yeah. Okay. Complete the following sentences by circling the correct word from the choice of 3 that is given within the bracket. These shouldn't be too challenging, I wouldn't imagine. So when we apply a tensile stress to a solid body, we change its what? Its compressibility, its flexibility, or its length. What do you reckon? I'd go with length. Good.
Yeah.
Yep.
It's going to be obvious.
A stress that acts to slide one atomic layer of a material over another is called a
shear.
Shear.
Stress. A shear stress. You'd agree with that, Timbo? Yeah.
That's where I was going with. Yep.
Yep. Shear stress. Exactly right. The gradient of the stress strain graph is always a measure of the body's.
What's it, guys?
I was
Rating of the stress strain graph is always measure of the body's
elasticity,
brittleness,
sort of brittleness, but elasticity is sticking out. No.
Like elasticity.
That's easy how much it would return afterwards. So brittleness is the next stress strain graph is always. Yeah, let's go with brittleness. Can only be wrong.
No.
No.
And you are wrong, Timbo. You're correct. You were wrong.
I was correct.
It's elasticity.
Yeah.
Elasticity is basically how much it stretches when you put a force on it.
At least I put my neck out
That's what the
there.
gradient-
Matt didn't put his neck on.
No, I didn't either. No, I was thinking brittleness or strength, so I was wrong as well.
I didn't think it was strength, but yeah, it was one or the other. Anyway,
Yeah. There you go. All right. Okay. Figure 1 shows a suspended bird watching platform. There you go. There's figure 1.
Ooh,
That
skyhooks.
allows the viewers to look down on the top of the trees. It consists of a uniform concrete beam of length L and mass M, which is suspended by 2 strong steel cables. I'm telling you, I'm not getting on that because it's only got 2 cables on it.
And then what are they attached to? Skyhooks.
Yeah, and how does it stop it from tipping? Anyway, we'll go with the hypothetical, right?
Yeah.
In order to ensure that the stress in the cables is well below their breaking point, it is important to know the values of the tensions T1 and T2. Hell yeah.
Yeah, you think so.
All right. The tension T2 can be written as T2 equals X times T1. What's the value of X?
Half. No, hang on a sec.
So you can see by the diagram there that the centre of mass is in the
sorry, I'm
middle
looking
of
at the
the
wrong thing.
concrete.
Yeah, sorry, I'm looking at the wrong thing.
Right.
Um,
T1 is acting at the end of the beam, and
L4.
T2 is acting a quarter of the way along.
So the mass is at that point. Which way is
Yeah.
it going to be? It's going to be higher than T1. And since
Yep.
it's-
Okay, I'll grant you that. How much
so
higher?
that's just going to be 6. So it's going to be. So if it's 6, it's going to be 4. I've got in my head that it's going to be 4.
I'll give you a hint. Consider rotational torques about the centre of mass.
Yeah. Why do I have that at 4? Hang on. Where's my calculator? Just do 4. Why do I get it as 2/3? I got to throw myself out there. 2/3. So that's going to.
Anyone else? Anyone else with an answer?
It's going to be inverse of that. Sorry, hang on a sec. But yeah, go on.
Yeah.
Yeah. 1.6.
What do you think?
I'll go with Timbo.
Yeah, 1.6.
Okay, let's have a look at. So I did it. There's a number of ways you can do this, but the easiest way is to consider rotational torques about the center of mass, right? Yeah. So T1 exerts a force that's going to make the thing rotate clockwise, right?
Yeah.
Yep. And T2 exerts a force that's going to make it rotate counterclockwise. Now, T1 acts at twice the distance than T2 does. So to balance out those torques, T2 must be twice the force because the torque is equal to the force times the distance, right?
Right.
Yeah. And so T2 has to be twice the value of T1.
Exactly. We read the question wrong, Timbo.
Yeah.
But out in the peanuts,
I was going to say, I noticed Nerd Alert had it and then deleted it.
He had it and deleted it. Yeah.
I saw it up there, Nerd Alert.
Yeah, I saw it too. I saw you put the correct answer up and delete it. Oh, dear. All right, so you agree with that one? You understand how that works now?
Yep.
Good. All right. Okay. Steel reinforcing beams are placed in the concrete beam to prevent it from cracking.
Well, that's good.
All right. Which one of these following diagrams shows you where you should place the steel beams?
Ooh, that's a tricky one. Because it depends what your purpose of the steel beams is. Prevent it from cracking, so I would be going with A or B. Because if you have it at C or D, you still have the potential of it cracking at the hinge point. So, and if you want to prevent it from cracking, you want to have the tensile through the bottom. So I'm going to go with A.
Well, let's think about it.
Yeah. Go on.
What kind of properties does concrete have, Timbo?
So what, concrete?
Yeah.
Well,
what's it like under compression?
It's quite good.
It's quite good under compression.
What's it like under tension?
Not good at all.
Not good at all.
Not good at all.
Yeah.
So you want to put the reinforcing steel where it's under
compression,
tension.
Under tension, right. And you want that in the tension flange. Yeah. But wait a minute.
Which bits are under
Let's think about where the tension flange is.
Yeah.
Look at the position of T2.
Yeah.
Exactly.
Okay? When you go out on the end of that thing, the tension flange and compression flanges flip. Now the tension flange is on the right-hand side.
Right.
So D actually is the better representation of what I would do.
So assuming that the overlap is at T2. Yeah.
Yep.
Okay.
That's right. Yeah.
Because you've got to
think of it like this, Timbo, that between T1 and T2, it's acting like a suspension, right? Mm-hmm. So it's like you're supporting the beam between two supports, and so it's going to sag. It's going to want to sag, isn't it? And so the bottom's going to be under tension, and the top's going to be under compression.
Yeah.
Okay. So you want the steel beams on the bottom in that bit, but the bit that's hanging out beyond T2 is cantilevered.
Yeah.
Right. And so it's going to hang. So the tension is going to be on the top, and the compression is going to be on the bottom. So you want the steel beams in the top part of that one.
So it's like
so D is in fact the correct answer. Well done, Blue.
No idea what Blue's talking about, but
D is correct. Well done. Yeah. All right.
It's question civil engineer, not a structural engineer.
4, I think we're up to. Yeah. Cast iron and mild steel are two types of steel. They're stress strain graphs shown in figure 2. If you tap a cast iron object or a mild steel object gently with a hammer, the hammer bounces off, right?
Yeah.
Which one of the statements below explains this? Is it that the two objects are brittle? Is it that the two objects are elastic? Is it that the mild steel object is brittle and the cast iron one is elastic? Or is it that the mild steel object is elastic and the cast iron one is brittle? What does this test tell you?
I'll go with D.
Okay. Well, they're both elastic, but
Don't be confused about what you know about the properties of
Yeah.
cast iron and mild steel.
Yeah, that's what I was trying to
Remember,
get
this question is asking you specifically what this test tells you about the two objects.
Because my first thing was yes, they're both elastic, but I'm just trying to get over and work that out in the graph. Mild steel, cast iron. So
I know I have a correct answer, or there is
well, you got B,
correct
B, D.
answers out in the peanuts.
It's either B or D.
Wait.
Because my initial thing was B. That they're both elastic. But
Note that the word gently is bold. You're only tapping it gently, you're not breaking it. All right.
But there's also an argument that I also know that D cast iron is also brittle. So
Is Nerdalert providing answers that that we're not worthy to see again?
he's getting rid of them. He's
should
not committing.
Yeah, based on the way the question's worded, it's B.
B was my initial answer. Yeah.
Okay. Yeah, because the key thing here is that brittleness is characterized by a low tendency to deform under stress before failing and a low tensile strength. Since the material did not fail in this test, then the characteristic of brittleness cannot be established. Okay? So you're not testing it for brittleness here. What you're doing is you're testing it well below that limit. And so you're testing the elasticity. It's showing you that both materials are elastic because the hammer bounces off.
Well, that's good.
So it's returning energy. It's returning energy to the hammer, which means it's acting like an elastic material.
That was my initial thought, and then I'm thinking, oh, it's a Paul quiz. I need to think this.
Okay, moving on. Question 5.
Now we get to a better one. I like this.
Yeah. However, if you hit the objects really hard with a hammer, the cast iron object shatters, but the mild steel one will deform. Now what is true?
So the mild steel's elastic and the cast iron's brittle. So
right.
Whichever answer that is. What's that one?
So are both objects stressed beyond their elastic limit?
No.
Or is the cast iron object stressed beyond its elastic limit, but the mild steel object is not?
C.
The cast iron object is stressed beyond its breaking point, and the mild steel object is stressed beyond its elastic limit? Which one? Or both objects are stressed beyond their breaking point?
Got to read the question, just to make sure. Ooh, it's not elastic. Is it still elastic if it deforms?
Yeah.
It's C. Yeah.
I was thinking about
it's B. Yeah, C. Yeah.
What was that? B.
No, I said C, B, C.
Oh, okay. Yeah. A low tendency to deform before fracture characterizes brittleness, whereas a tendency to deform before fracture indicates stressing material beyond its elastic limit, meaning that upon removing the applied stress, the material will not return to its original configuration, and so the correct answer is in fact C. Well done.
Because B is technically true, but C was more accurate.
Yeah. Okay. A circular rod with length of 1 meter and a diameter of 10 millimeters is made from the mild steel as shown in figure 2. Right. This rod is placed under tension with a stress of 240 megapascals. What force must be applied to the rod to provide this stress?
Circular rod, remember?
You've got a graph there. All right, you can use that graph to
of course. Yeah. So we want to end up with 240 MPa, which is there, and we're doing circular, which is made from mild steel. The strain number there is, if that's 1, so 4.4 by 10 to the minus 3. That's the strain. Yeah, with stress. is that the same as the stress? So let's go with it. 0.1234. Yeah, 0.4.
You might need a calculator.
Yeah. Oh, do I have to do calculations?
Yeah.
Oh. Can I look up a table or find a YouTube video that tells me the answer? Okay, I get the strain is 0.4 by 10 to the minus 3.
Yeah, okay.
And from that to place with the force, how do you go from strain to force?
Yeah, how do you? What is the stress? It says a stress of 240 megapascals. What's a Pascal?
That's what I use when I run out of pencil.
Pascal's pressure, right?
Yeah.
Right.
Which is what? Force per unit area.
Right.
Yeah.
And say if you've got a one diameter 10 mil, your area is. Where's pi on this thing?
So let's see, we got what? 240 times 10 to the minus 6.
Oh, there's pi.
10 to the minus 3. B.
So area is 16.6 mil squared. It's applied for the full. Well, it's time 1 anyway, so yeah, that's okay. Force equals stress times area. So stress is times 1 point. Oh, what does that?
Come on.
It's got the answer down there too, and I'm not getting it. But I'm trying to work out where the.
All right, so the force
I'm
is
missing
stress
something,
multiplied by the area. Okay,
Yeah.
because stress is force per area. So
I
all
get
you got
the
to do
stress
is
bit.
multiply the stress by the area. You've been told what the stress is: 240 times 10 to the 6, right?
Yeah.
And the area is just half the diameter, which is 5 times 10 to the minus 3. So you square that and multiply it by pi, and then multiply it by 240 times 10 to the 6. And the answer you get is 18.8 kilonewtons. Or I'll accept 19 kilonewtons.
Yeah, Nerdalert was
Nerdalert
closer.
wants to round it up to that. That's fine by me. I will accept Nerdalert's answer out there as being correct.
Correct. Yeah, no, it's no.
All right. Well done. We'll move on. Otherwise, we'll run out of time. All right. Right. A circular rod with a length of 1 metre and a diameter of 10 millimetres. The same sort of thing, right?
Same run, yeah.
Calculate the total strain energy stored in the rod when this stress is applied. How do you calculate the strain energy?
No idea.
No? Getting too complicated now?
I haven't got any. Have never done anything like that. So I'd have to look it up. Let's see if I can find it. Well,
you can use the graph to calculate it, Timbo.
Oh, can you?
To help you calculate it in some particular way. Yeah.
Go on, Matt.
It's a particular
Get some
characteristic of the graph that you use to calculate strain energy from this kind of graph.
Energy is theta for stress over strain. Is that correct? That's the formula. Young's modulus. E is equal to stress over strain.
Young's modulus is equal to stress over strain. Yep.
Yeah.
That would give you the gradient of the graph.
Oh, okay.
What would you get if you multiplied stress by strain?
Hopefully the right answer, but
what you would get is the the strain energy per unit volume. So if you calculate the area under the graph for that stress and then multiply it by the volume, you'll get the total amount of strain energy. And that is indeed what you have to do. You don't need an integral for it, nerd alert. All you need to do is calculate the area under the graph, and the area under the graph at that point is just a triangle. All right, so it's half base times height. And so you get half times 0.4 times 10 to the minus 3 multiplied by 240 times 10 to the power of 6. That's the area under the graph. And then you multiply it by the volume, which is pi times 5 times 10 to the minus 3 squared times 1 metre in length, giving you the volume. And when you calculate all that out, you get 3.8 joules, which doesn't seem much, does it?
No. A lot.
Okay, let's go onwards. Okay, here we've got a light hanging from a pole, right? And it's hanging from the pole in such a way that there's a cable from A to B.
Is the pole frangible?
And you've got a rod from B to C. Okay,
go on.
So we're in physics world here. So the rod and the rod and the cable have no mass. Only the light has mass. Okay. And the angles are shown. The angle of the dangle is shown there. So what you have to do is, which one of these statements is correct? Both the cable and the rod are under compression.
No.
Both the cable and the rod are under tension. Cable is under compression or the rod is under tension, or is it the other way around? Cable is under tension while the rod is under compression.
So I'm just checking. The cable is under tension and the rod is under compression.
Right. All agree?
Yep.
Yeah.
Yep. All right. Good. Because that's the correct answer. That's a nice, quick, easy one. All right. Now, what you have to do is calculate the magnitude of the force in the cable AB.
So we've got 20 kilos going down, and that's offset by the force back to. Now, this is not my area of expertise. I'm making a bit of a guess here.
What's not your area of expertise? Doing maths?
Yeah. No. Get out of the maths. No. Structural physics. So, obviously the force is coming down, but it's offset back into the rod. And
I'll give you a hint. Once again, it's an easy problem if you consider rotational torques about point C.
About point C.
Yeah. So the tension in the string, in the cable, is going to make it want to rotate counterclockwise, right?
Yep.
And the weight is going to make it want to rotate clockwise if you're looking at from the side that you're seeing it from.
Yeah.
And now all you've got to do is calculate those torques. Obviously, the forces are acting at an angle to the line joining B and C. So what do you have to do?
Because you've got two vectors. You've got the vector going from A to B, and then you've got a vector going from B to C. And then you've got the weight of the light going directly down. That's how I was looking at it.
You've got to resolve those forces into forces that are perpendicular to the line BC, right?
Yeah.
Yeah. All right. So what you need to do, counterclockwise torque is given by that. Okay. So it's the tension multiplied by the cosine of 30 degrees times the length from B to C, whatever that is.
Yep.
Okay. Whereas the other torque, right, acting by the weight, is given by mg by the cosine of 60 multiplied by L. All right.
Yeah.
That'll give you those forces that are perpendicular to the line BC.
BC. Okay.
Okay.
Yeah.
Yeah. And then you equate those two together, right? Because they have to be equal because the thing's obviously not rotating.
Yeah.
All right. So when you equate the two, you get that.
Yeah.
And that, of course, eliminates L because you just divide both sides by L. And then you divide by cos 30 on both sides to get T equals that.
Yeah.
All right. And then when you evaluate that, you get 113
13
newtons.
newtons. Okay, I see.
Yeah, there you go. Okay. So there you go. That was the trickiest part of the quiz. Now we'll go for something a bit easier. Right, in a laboratory class at school, Lee is given a spring with a stiffness of 20 newtons per meter, sorry, and stretched length and an unstretched length of 0.4 meters. He hangs it vertically and attaches a mass to it so that the new length of the spring is 0.6 meters.
6 meters, yeah.
Assuming the spring has no mass, because we're in physics land, what is the value of the mass attached?
Newton meters. So
What do you think, guys?
Gun?
Well, he's giving you a spring constant of 20 newtons per meter.
Meter, yeah.
Yep.
Right.
And the spring has stretched by an amount of
0.2 meters.
0.2 meters, right?
Yep.
So you'd think that'd be it's not working. I shouldn't have to do that.
It should be just 0.2 times 20.
Which is?
0.4 newton. All right.
4
newton. Yeah.
It's asking you what the mass is.
So if it's 4 newtons.
That's the force, yeah, right.
Yeah.
So now we need the mass, got to divide by 9.8.
Yeah. Which is divided by 9.8. 4 divided by 9.8 is 0.4. Let's say.
Very good. All right. So you do that, m equals kx over g, put those numbers in, and you get the mass is 0.41 kilograms. Well done. Nerdlet's answer is approximately correct. I'll accept that.
No, he failed because he used grams instead of kilograms.
Yep. Yeah. All right. So now what he does, he pulls the mass down another 10 centimeters. All right.
Yeah.
And how much has the potential energy stored in the spring changed?
Well, if we said the Newton energy was 4, and we've now changed that to, you said 10, so we've gone to 6, so 4.
So it was stretched 0.2 meters. Now it's stretched 0.3 meters.
Yeah, so we're saying 60%, or have I gone too far?
No, I want to know how much has changed.
How much potential energy stored in the string now? Yeah, okay. So the force has changed to 0.6.
How do you calculate the potential energy stored in a spring?
You ask your physics teacher. You say, how do I calculate the potential energy? I can't remember the potential energy.
Right, your potential energy is given by half k delta x squared, where delta x is the extension. Right,
yep.
Half kx squared. All right.
Yep.
So before he pulls it down, it's stretched 0.2 meters.
Yeah.
So half times 20 times 0.2 squared equals 0.4 joules.
Yep.
All right. And in the time after, it's stretched by 0.3 meters. So same equation, you get 0.9 joules. So it increases by
0.5, yeah.
0.5 joules, half a joule. And your last question isn't one at all. That was the quiz for today.
That was it.
There you go.
Well, thanks for that.
That was it. Okay.
That was fun.
How were we for timing?
We're doing well on time. We're just about to finish. I do like how Nerd Alert kept deleting his answers.
Good. Well done, Nerd Alert.
Nerd Alert. Yes, you got most of them right, Nerd Alert. So you can't. You're pretty on par. There we go. Thanks for that. I think we're about to run out of Zoom, so I might kick us out.
Kick us out? Yeah.
Yeah. So let's push some back over here. Let's have something light. What about? I got something for blue. We did some woodworking. You want to see some woodworking, blue? Let's run away. Oops. Hang on a sec. Get this back up here. What have you guys seen in... You still don't share my screen, haven't I? So you should see that. Yep. Let's get that out here. There we go. I was going to ask Blues if you've ever used any of these joinery techniques.
I can't stay.
Ooh. This one amazed me. You know what it's going to do? Oh. Have I lost everybody?
No, I'm here.
Oh, no, that's all right. I was just checking because I wasn't getting any sound back. I was just making sure I wasn't... It's all right to talk to dead air. I just want to make sure I hadn't lost you. Get back dead here. Okay. Are you still there, Blue, or you run away?
I'm here.
Okay, I want to know if you've ever used this technique in your woodworking. Do you know what he's going to do?
I have not. I got an idea what he's going to do, though. I've seen this. Yeah, now you put the nail through it and then
takes it back up again.
Yeah.
And now he's got an impossible. How did you do it? I like his joint.
That is a cool. I like that joint.
There's a nice joint in it. I've seen this done before. I've seen this done before. This one, using a screw to tighten up a dowel.
I don't try drilling a hole the right damn size to begin with.
Yes, it would work better. It's fun. You can see what he's going to do. It's pretty straightforward. I've never done this, but I have seen it. Makes a nice joint. Now I think this is what that silly video from last week, the last show, was some sort of relation to this, but obviously you can't do it with a 4-way joint like the other guy was trying to do. Although not sure that's a pretty joint or not. I think it's a little bit ugly myself, but anyway. But this is pretty.
That type of lap joint's nice.
This one's pretty because initially I thought he was going to put a dowel in it, but that's not what he does. So. That's nice. That's pretty good one. There we go. I thought this was pretty basic compared to the other stuff he did. There we go. Don't know what that one's about. Yeah, nice stuff. Well, what else have I got? 20? We got some Wally. Let's put on some Wally. You want to get a cup of tea? I'll put this on. I'm going to nick off and get a drink. I'll be back in a sec.
G'day everybody, where's Wally here? While we all wait for Elon Musk to do his thing and pop Starship into orbit around the planet, which is going to be really, really great, I thought we'd have a little bit of a flashback to the first time he did something fun and fantastic with his red Roadster. I made this video quite a few years ago, so please forgive me if it's a little bit rough, but please enjoy the fun that was Starman. Oh, and P.S. there are still flatties out there who really love to hate on Starman. I wonder why. G'day and welcome from Where's Wally. It's time to update my video on SpaceX Starman and the Australian Crocodile Cloud. Originally I showed that the cloud was visible on Himawari 8 and Epic Discover as well. I have since found
Does
that
Timbo know his stream was suspended?
with reality. A link to the original version is in the description below. Taken on the 6th of February at 2200 UTC, the first image from Starman here has Western Australia, the morning Terminator, and above Starman's head is a distinctive crocodile cloud.
That must have been that last video. Hang on a sec. When was it suspended? Well, we got through the quiz. Let's have a look.
I'll bet it was that last woodworking video.
Yeah, it must have been the sound in the background, I think. I should have turned it down. Oops. I think the chat's still up, so... Oh, stream's back, apparently. Yeah. Let's... Why can't I see it? Where's it gone? The stream no longer blocked due to copyright. So it's no longer blocked. Okay, so they just stopped it while that was on. Okay, so okay, there you go. I'll have to watch out for that.
Yeah, so if you're going to put that one up on your channel, Timbo, you just need to edit out that video.
Yeah, we'll do that. We're still partway through our friend Wally. Sorry, I'm just checking. We're good. Watch it live. Yeah, it says it's okay. Okay. Sorry guys. We're back. So did we catch any of Wally? Let me out there.
I'd restart Wally if you're going to do it.
Let's restart Wally.
How much?
Yeah. We'll go back to the beginning. I'm turning up a little bit too because he was a bit quiet.
Yeah, very quiet.
G'day everybody, where's Wally here? While we all wait for Elon Musk to do his thing and pop Starship into orbit around the planet, which is going to be really, really great, I thought we'd have a little bit of a flashback to the first time he did something fun and fantastic with his red Roadster. I made this video quite a few years ago, so please forgive me if it's a little bit rough, but please enjoy the fun that was Starman. Oh, and P.S. there are still flatties out there who really love to hate on Starman. I wonder why. G'day and welcome from Where's Wally. It's time to update my video on SpaceX Starman and the Australian Crocodile Cloud. Originally I showed that the cloud was visible on Himawari 8 and Epic Discover as well. I have since found that a few more camera angles that comport with reality. A link to the original version is in the description below. Taken on the 6th of February at 2200 UTC, the first image from Starman here has Western Australia, the morning Terminator, and above Starman's head is a distinctive crocodile cloud that we will be watching. Next is the Himawari 8 showing Australia in all its glory and is taken at roughly the same time, and the crocodile cloud is again very visible over Western Australia. Next we have an image from Starman's second orbit, again, that showed the crocodile cloud over Western Australia. Next we have a Himawari 8 image taken at the same time as the second orbit. Then we have an Epic Discover image taken from 1,000,000 miles away, again at the same time as the second orbit, and it clearly shows the crocodile cloud. And then we have a Russian Electro L, which was a high resolution image, which I finally dug up from the FTP server. It was not easy to find. And again, as we zoom in on the crocodile cloud, it's clearly there and visible. The ISS was over Tasmania during Starman's first orbit of the Earth. The matching clouds are circled in red to make them easier to see. Can you see the ISS down there? Well, of course you can't see the ISS. It is way too small at that scale. It's at 120 metres long versus the 12,000 kilometre diameter of the Earth. It's about order of 5 magnitude smaller, so of course you won't be able to see it. During Starman's second orbit, the ISS was now over Western Australia and passed over the Croco cloud. The ISS passed over the cloud, but it was so low and too close. Funnily enough, you could only make out the mouth as it passed behind the ISS. So, while we look at this peaceful view from 5,000 kilometres away, remember that we saw that the video feed from Starman was showing you the exact same cloud feature. As the other space-based cameras were showing. And also
I hope that music's not
note
copyright.
that there are there is also CubeSats with cameras, and the current number in the constellation is in the order of 100 or more. Then during this time it passed through the inky darkness of the shadow of the Earth, and then slowly Starman appears, and it was followed by some cosmic flashes, Some city lights were able to be seen on the Earth, and then there were some storms and lightning were clearly visible and flashing in the background.
There you go. I hope that music's not copyright. I was trying to see where Starman is now. According to this, ooh, he's a long way away. You're not there, Matt, are you? Probably no. What have we got list? I did have. We did talk about to Bev earlier, so I'll put that up again because that was just the same dribble as last time. We do have a Mr. Keegan. What's Mr. Keegan got?
Looking for a website or domain?
No, not particularly.
A general consensus that the Earth is a flat plane and that the Sun and Moon circle. We're all doing well, and thank you for joining us for another video. Now, whilst flat earthers can't agree on a complete flat Earth model, they do seem to have a general consensus that the Earth is a flat plane and that the Sun and Moon circle above it whilst maintaining a fairly constant altitude, although they can't agree on what that altitude is. The distance from the North Pole to the South Pole is about 11,800 miles, which would put a flat Earth at around 23,500 miles across. Now, if the Sun and Moon were hundreds of thousands of miles high, then they should be visible high in the sky 24/7, which obviously they aren't. Which sort of forces the claim that they are in fact much closer to the Earth, with general distances given of only around a few thousand miles.
The astronomers now teach that the Sun's distance from the Earth is from 92 to 93 million miles, whereas it is proved to be under 2,400 miles.
Even around 3,000 miles high, though, the Sun should never set. If the Sun were above one edge of the flat Earth and you were at the other, 23,000 miles away, the Sun should still be 7.5 degrees above the horizon. When the Sun's above the equator, and if you're on the equator too but directly opposite, the Sun should be 14 degrees above the horizon at its lowest point, rather than having gone behind the horizon 6 hours previously. The other big problem, though, is what their angular sizes should be doing. When we view an object, we see an angular size, which is the angle across the object that we see based on its physical size in relation to its distance away. The physical size of the object won't change, but as we change the distance, then the angular size is directly affected. So if we have an object that is 5 degrees wide when it's 10 meters away, and we double the distance to 20 meters, then the angular size will halve to 2.5 degrees. If you're in Egypt when the sun is at high noon, it would be 3,000 miles away from you straight up and has an angular size of half a degree. 6 hours later, when we see it set, it's now 7,000 miles away across the Earth's surface, meaning the sun would then be 7,600 miles away from you, which is 2.5 times further than it was at noon, and so it should appear to be only 1/5 of a degree in angular size. But it's not. Both the sun and moon's angular size remain constant from one horizon right overhead and to the opposite horizon. Now, flat earthers have put this down to atmospheric magnification, claiming the Earth's atmosphere is magnifying objects more and more as they get further and further away, which causes them to always appear the same size.
But throughout the day, as you're watching it rise and go over you, and you can take pictures of it throughout the whole day, the angular size change is what you would expect with a sun about 93 million miles away. So unless on the flat Earth, the sun is also 93 million miles away, there's nothing on the flat Earth that would match.
Do you understand how angle of incidence works?
Angle of incidence and refraction, yes, I do. A change in density or temperature changes the refractive index.
And does that magnify an apparent size or something?
Does that magnify an apparent size? No, an angle of incidence doesn't magnify an apparent size of something.
So the sun does have angle of incidence due to refraction, correct?
Yeah, but a tiny, tiny, tiny amount until it reaches the horizon.
So that would change its apparent size as well.
No, it would not change its apparent size, because angle of incidence change doesn't change the apparent size of something, it changes the apparent position.
The first obvious problem with this, though, is why is it only happening to celestial objects? Why don't planes, birds, balloons, and everything else in the sky also stay the same size as they get further away? The bigger and less obvious problem, though, that I think exists is the problem of the shape of the atmosphere that would be required to magnify objects to such an extent. But since we're about to talk about the shape of atmosphere, it seems like an appropriate time to tell you about today's sponsor, Squarespace. Squarespace is one of the leading... angular size reduces. When an object's angular size reduces as it gets further away, the angle with which the light from it is entering our eyes is decreasing. So when we magnify an object and we're increasing the angular size that it appears to us, we must be increasing the angle that the light is entering our eyes, which is done via refraction. This is where light travels through mediums of different densities, and as it moves between them, the change in density will cause the light to bend. Now, how much it bends depends on multiple factors, such as the difference in densities between the mediums and the angle with which the light is traveling relative to the mediums. Now, we can't change the incoming angle of objects when they're at very low angles.
I think we all get that. I'm going to pause that. I think there's nobody here that just needs to have that all explained to them. That's a bit scary. Okay, I put out a poll to see if I should play some more dirt. And so far I've got 100%. Which is 1 vote. See how many people I got left out there. Let's have a look. Oh, still 7 people out there. Okay, I have, let me know in the chat, I've got 2 things here. I've got CC we did, so we've got the Star Trails by this one. I'm just sitting here watching the whoa, that'll give me a strike. You got Star Trails by They Live Truth. They Live well, that's a scary name. And the other one I got here is flatsoid. Yeah, let me see.
And what were those?
This is flatsoid and yeah, I gotta put that in the right spot so you can see it. Put that up there.
Details the lat and long based on?
Protothad's video.
Yeah. So yeah, what were the latitude and longitude based on? What kind of coordinate system? A spherical coordinate system, right?
Lat
That's
and
where you
long.
get that.
No, it's just simply the lat and long. It's a
Yeah, which is a spherical coordinate system, right?
Cartesian.
It's a spherical coordinate
Cartesian.
system. It's a spherical.
You obfuscating from my point, by the way. Like I'm saying.
No,
so,
I'm just asking where you got the details from.
Can I finish my point first before you try?
Yeah. Sure, we know where.
Okay, so like you said, remember you said it's not based on Mercator, so I've already got 1, 2, 3, 4 citations or reference on the sides, which it says Mercator projections. Okay, now we're looking on the left. This is the AE map. After plotting all the circle of equal altitudes on the AE map, we see that the fix was 511 kilometers off from the actual position.
Yeah,
okay,
so not accurate in the slightest.
Okay, but let's go to the Mercator. Now, this is the Mercator. This is what the projection is based on. Your actual nautical.
The Mercator is a projection. So what do you mean? This is what the projection?
The charts are based on this Mercator projection.
So which charts specifically relating
nautical
to what?
charts.
Nautical charts relating to what? Celestial navigation?
Yes.
Specifically.
All I got on the right. What is the chart?
Yeah. You've got two different things there, right? You've got two different citations. So we're going to focus on the one there that says about the most nautical charts using Mercator projection. I'd like that to be specifically tailored to celestial navigation. So do you have one that says nautical charts for celestial navigation use the Mercator projection?
What is a nautical chart?
Yeah. But again,
what
I asked you.
What is a nautical chart? What does nautical mean? What does nautical mean?
It's a simple question, Flatsoid, right? Do you have a citation that says nautical charts used for celestial navigation are based on a Mercator projection of the globe? Because that's what a Mercator is, right? It's a projection of the globe. We know that.
What does nautical mean?
I'm pretty confident that any nautical chart that's actually used is not based on a Mercator prediction. But anyway.
That's not the question I'm asking you. Can you answer my question?
What is nautical?
Do you have a citation?
All citations. What does nautical mean, Craig?
Like celestial navigation.
Sometimes I can't listen to FTFE. Let me try this one. I'm just going to turn the sound off for a sec. Because there's a bit of music at the beginning that we can't have. So you get it. We're talking about Star Trails Explained. Okay, so
of the stars going around.
Okay.
Look at this footage of the time lapse of the stars going around. That is, again, the wheel in the sky that keeps on turning. Now, how is this possible with the heliocentric model, with the supposed sun moving at 500,000 miles an hour through space?
Why can't they see anything? Oh no. Is it? My what's he shows it as blank. But I can see the bottom of it. What's going on there? Is that what the YouTubers say? I think it's just catching up. Hang on, what's going on here? Ah, okay, I see. I got the wrong.
Well, all the other so-called planets.
That is in the wrong YouTube. Wrong.
navigation instruction manual that shows it's based on a globe. So do you have...
Close down all the ones I don't want. There. Too much open, that's the trouble. There we go. And then this one, drag you into there. There we go. That's what I was trying to see. Sorry, Peanuts, about that. Production values. I'm going to sack that production manager. Go back to the...
Of the stars going around. That is, again, the wheel in the sky that keeps on turning. Now, how is this possible with the heliocentric model, with the supposed sun moving at a 500,000 miles an hour through space, while all the other so-called planets, including Earth, of course, are going round and round again as this vortex goes through supposedly endless space? Give me a break.
One day I wanted to work out how many millions of years that image would take, because of some of the speeds and stuff are just wrong. So you had Jupiter going around, that takes 200 and something other years. So there must be at least 5,000 or 6,000 years in that clip they show.
Now, talking about this Earth we live in, forget the northern hemisphere, forget the southern hemisphere. All we have is the inner circle and the outer rim, or the outer circle, and the Antarctic ice wall that holds the oceans in. And this is something that's not being made up, that we can see with our own eyes with this footage from a helicopter view above Antarctica,
off the ice
the Antarctic ice wall. And take a look at this footage off the coast of California. Look at the ocean from this vantage point. If we lived on a ball, a spinning ball hurling through space, how do we get this footage of this ocean? And you can see the horizon and the water level. If we lived on a ball,
how do you
that
get
water
the
should be going down. We should be looking down. It's rising up to eye level.
No.
So this is crystal clear for those that have eyes to see.
Only if you got a ball
100%. We live in a stationary flat Earth. And again, water does not lie. Water always seeks its level. And again, you can forget the ridiculous notion of the northern, western, southern, eastern hemispheres. All nonsense. And of course, in the school textbooks, when you look at the ridiculous ball Earth, and they show obviously the inner core, supposed inner core, how would they know what it consists of when the largest drill only basically went down 7.6 miles? So how would they know this?
People
and again, of
look
course,
at
just a cartoon
things
drawing,
differently
a
than
fake
you
phony
do.
ball Earth, showing the supposed inner core. And again, people that believe this, they'll believe anything because they have been blinded by science. Now, before getting back to the star trails, what this video is all about, just take a look here at the ridiculous notion that these huge ships, this one being dry docked for repair, for maintenance, can cling on to the side of a baller, travel up around the sides, go to the bottom of Antarctica that supposedly is on the bottom of the world we live on. Completely ridiculous. Again, just take a look at the size of these people compared to the ship. And take a look here as well, this footage. Again, the magnitude of this ship. And somehow, again, this weaker force called gravity being able to hold on. Now, take a look here. Somehow, these grass seeds are able to defy gravity. You know, grass seeds can defy gravity, while gravity can hold down this ship. Things don't add up. Things don't make sense on what we're told. Now, let's take a listen here to those that believe in science. And let's take a listen to what Neil deGrasse Tyson has to say here regarding gravity.
What is gravity?
You have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things.
Yeah.
We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
And here's the thing is, you have a lot of science geeks online pushing these theories of gravity, evolution, the string theory, theory of relativity as fact, when these so-called leaders of science, such as Neil deGrasse Tyson and Michio Kaku, these so-called high priests of science, nothing but religious nonsense. Let's take a listen to what Michio Kaku says here.
In science, we always say that you make observations, you have a theory, you can go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork. It's guesswork.
It's leaps of logic. It's guesswork. And this is definitely pseudoscience. It's not actual science. And again, the people that have been conditioned to believe in this nonsense, ball Earth, can't get past it, can't get past the lies. And basically, for many, it's the point of no return. Now let's get back on topic with the star trails. That's what this video is all about. Let's get right to it. Now taking a look at the flat Earth model here, and again, I said it many times, where we don't know the full dimensions of the flat Earth. This is basically a representation, and the point is again, when it comes to star trails, I have to set the foundation so people understand exactly what they'll be looking at with, again, the sun and the moon that circle above like a clock. When you look at the moon from the inner circle, like I said earlier, the inner circle, not the northern hemisphere, say, for example, from China or Russia, when you look at the moon, you're going to see its face on one side here. You see here that how the northern hemisphere moon looks like. Of course, we only see one face of the moon, and here's the southern. So it's very, again, easy to understand why we see the moon from...
That wouldn't work, because if the moon was over the other side, then China and Australia would see the same side face. That doesn't work.
Different aspects of the inner circle and the outer circle, and why they appear as they do. And of course, we see the sun and the moon in the sky often as the sun circles above. Say, for example, you're in California, and say it's about 2 o'clock, 3 o'clock. On many occasions, you'll see the sun and the moon in the sky at the same time, with obviously both of them above the horizon at the same time. What is the other side of this all-called ball Earth getting as far as moonlight or sunlight during these periods of time? Can't happen. Now, regarding star trails, once again, so when you're looking from, again, the inner circle, you're looking as the sun and the moon circle above the flat Earth, you're looking towards the south. Now, when you're...
Nah, enough of that. Doesn't work. Who we got left? I think Paul might be lurking, but I think everyone's wandered away, so we might get time to call it night, I think. Let's have a look.
Yeah, I think so.
Yeah, I think we're at that sort of time. I might wander through that. Oh, thanks, Peanuts. Once to the left. Sorry about a little gaffool halfway through, but I think I've still got 7 or 8 still looking. I'll run it again on Wednesday. We'll see where we're at. We'll pick up on some of this video later on. We've got a few people to talk about it, but I think it's time we